Okay, so I want to take some time to work problem number 27 from section 11.2 because I believe there's a little bit of confusion with what the directions or what the example is showing. And I'm going to work this just a little bit different, but hopefully it'll make sense to you. So what we had here was a picture of a 55 Newton weight hanging by two wires. And so we had our first wire, which I'm going to call F2. Actually, that was our second wire, hanging out in this direction. And then we had a longer wire, which they called F1. And these are vectors, by the way, hanging out in this direction. And so what they did was go ahead and extend this up and look at these angles that we made here with a horizontal going across, and they call this angle 58 degrees, and this angle was unknown. We call that one alpha. So the first thing I'm going to do is take this picture and I'm going to move these vectors down to the origin because that's where we're used to measuring things from. So bear with me here while I do this. I'm going to go ahead and bring my weight down here, and this is my 55 Newton weight. And this actually would be the resultant vector of my other two force vectors that are acting together here. My, I should say my second vector. Okay, my vector F2, we're going to put it right here so that it is a vector in component form. And then I'm going to come up here and I'm going to put in my vector F1. And again, I am placing these things so that they're sitting in component form. And if we remember correctly, we can write a vector if we know its magnitude and the angle that it makes with the positive x-axis. So for my vector F2, the angle I'm interested in is this angle right here. Sorry for that stray mark there. Let me get rid of that thing. But we're looking for actually this angle right here in this corner. Not the angle we were given, but let's look at how we can actually translate that down into the angle we're looking for. So what we had here was they went ahead and extended this vector, but basically the measurement that we received was this angle here, which was 58 degrees. Well, if this is a 90-degree angle here that it makes with my positive y-axis, and this, then the total angles in any right triangle can only measure up to be 180 degrees. If that were the case, then I've got my 90 degree and 58 plus, I believe, was it 32? Would measure up to be 90 degrees. So this angle here in this corner is 58. This angle here in this corner is 32. Then if we extend this back down here, what we're going to find then, once again, if I look at now, let me highlight it here. This distance from here, actually not highlighted, but put it in yellow, to here has to be 90 degrees, which means that this angle sitting over here in this corner has to be 58 degrees as well. And so when you look at the picture, or the way that the example does it, you will see that the angle that they use, that vector F2 makes with the positive x-axis, is actually 58 degrees. We can run the same kind of scenario and we will find that the angle that F1 makes, actually not with the positive x-axis, but with the negative x-axis, is going to be the alpha. So let me go ahead and redraw this picture on my next page so we can actually get working on this. Okay, so let me go ahead and redraw this thing in a way that now that we understand where those angles come from, we can go ahead and get all our measurements off. So here was our vector F2, and we saw that this vector made a 58-degree angle with the positive x-axis. We also had our vector over here, F1, and the angle that it made with the negative x-axis was actually alpha. But when we write vectors, we write them using the angle that they make with the positive x-axis. So why don't I go ahead and call this angle here A? Because if I can find A, which I should be able to find, then what I can do to find alpha is just take 180 degrees and subtract A from it. So hopefully that makes sense. Now, our resultant vector, if we remember here, was a vector that came straight down along the negative y-axis. This was our resultant vector here, capital F. And let's see what we know about this scenario. Well, first thing I know is that, let me change my color on here, is that my resultant vector F comes from adding F1 and F2 together. Now remember, we did have a weight hanging down here of 55 newtons. Now there's a couple of things that I know about my resultant vector F. First off, I know that the magnitude of this vector is going to be 55 newtons. In addition, just looking at the vector, I can see that this is a component vector which has its initial point at the origin and its terminal point at the ordered pair 0, 55. So that gives me some information about my resultant vector. Now let's go ahead and write each of our vectors F1 and F2. I'll start with F1. And remember, if we know the magnitude of a vector and the angle that it makes with the positive x-axis, we can write that vector. Now, we were told that the magnitude of F1 was 40. So what we're going to see here is that we can write this vector as 40 times the cosine of the angle it makes with the positive x-axis. I'll call that A. And then 40 times the sine of that angle. For the vector F2, we're going to go ahead and write it. Now this time we don't know the magnitude of F2, but we do know the angle it makes with the positive x-axis. So when we write this, it's simply going to be the magnitude of F2 times the cosine of 58 degrees and the magnitude of F2 times the sine of 58 degrees. Now, since these two vectors must sum up to give me my capital F, then I know that capital F would be the sum of these two. That is, the first component is going to be 40 cosine of A plus the magnitude of F2 times the cosine of 58 degrees. And forgive me, I'm going to have to step down here. But the second component is going to be 40 sine of A plus the magnitude of F2 sine of 58 degrees. Now I'm going to go ahead and move on to the next page here. We'll do a copy of this and bring it down with us because I'm running out of room. Let me move on to my next page here. Okay, since we know that our vector F, sorry about this, our vector F here is the vector. Okay, sorry for the skipping there, but let me kind of back up a little bit. We saw from the last page that the vector F could be defined as the vector having components 0, 55, but it could also be defined as the vector having components 40 cosine of A plus a magnitude of F2 cosine of 58 and 40 sine of A, magnitude of F2 times the sine of 58 degrees. And of course, we know that when two vectors are equal, their components must be equal. So what we're going to do now is set these two components equal. So setting their first components equal, we get 0 is equal to the 40 cosine of A plus the magnitude of F2 cosine of 58 degrees. And then setting their second components equal, 55 is going to be equal to 40 sine of A plus the magnitude of F2 sine of 58 degrees. And what I wind up with here are two equations with two unknowns, which we can then solve using some simple algebra. Hope this helps.